I'm Ian Buchanan. I'm a senior solutions engineer for DevOps. But across the 4.5 years I've been here at Atlassian, I've played various advocacy and evangelism roles around software development. In the first role that I had about 4.5 years ago, I was on a team with some of the longest Atlassian developers on that developer advocacy team. So a lot of this story comes from either discussions with them or in exploring our own Confluence spaces to understand our history. So I'm connecting this up to governance in a kind of different way than we have in some of the earlier talks. So nominally, this is about JIRA and some of the associated products have moved from monolith to microservices. But along the way, we've had to discover some ways to govern those applications, new ways to look at security. And so we'll pause across this journey and have some conversation about what those were. So I don't know, I don't know how many people would remember this 1966 film? Yes. Okay, so this is, like a team of scientists are shrunk down to fit inside a human body. But I fear this model of miniaturization is how too many developers think about microservices, right? So we've got our big server, we'll just shoot the right ray at it and shrink down the microservice. And it's as if the term microservice is focusing us on the wrong aspect, like it's the size only about microservices that matters. I think what's really important is how microservices fit together. And so it's really about the system, the larger whole. And I'm not even sure that this idea of system goes far enough, that more and more these days, applications depend on things outside of our own company. They depend on, a public-facing website has different services it uses for authentication. There's another system that it's using for customer tracking and something else for financial data. And so there's a whole world of services with APIs to leverage. And so maybe a better term is ecosystem. So I'm going to kind of draw some attention to this. We'll circle back at the end and kind of discover how that fits in, especially with governance and security. So to go way back in history for Atlassian, JIRA is the first product that our founders came up with. Probably not in 2002 exactly. They spent a little bit of time doing a service offering, trying to do support for another customer. But at the time, I don't know if JIRA could have been written any other way. So many of you may be thinking, if you're starting today, why would you even start with microservices? And if you are, you may already be thinking like, hey, and we regret it. Like, if you're starting out, oh man, I want to tear these things apart. But this story isn't about regrets. What I think is that, like, as products get started, they really need to get out there and make sure that they're solving some real customer problems before they start worrying a whole lot about architecture or starting over with microservices. But the rest of the story is really how we have adapted and evolved our architecture over time and some of the choices that we had to do the same. And I think if we can get there, that means other people can too. So if anything, I hope this story helps you do some of those transitions in less time, and there's no reason to just wallow in regret about your monolith. So when we started out, we were pretty like pathological case of a monolith. If those of you who remember JSP, that's kind of the frame of mind people were in. It was like pour all of the business logic into a page, and that's how you build an app. But actually, it wasn't even that great. At least JSPs, you can kind of make changes on the fly, and you don't necessarily have to restart the application. But it was certainly the case with JIRA that if you wanted to make a change, you had to bring the application down, restart it, reinstall, restart, and all of that. So for its day, that's kind of pretty much the norm. But when we were shipping it, we really had a lot of customers who wanted to do a lot more than it did out of the box. As Mike mentioned, the JIRA was actually a kind of reaction to Bugzilla, and for that code base, that's something that people were customizing quite heavily through just like changing the scripts. So we shipped JIRA as kind of open-ish source, and in fact continue to do that to this day, which means if you're an existing customer, you can get access to our source code. But initially, this was the only way that customers could do any kind of modification to the product itself. And so, I don't know, if you imagine that, that back in the day when you're having to bring that down, make some changes and then bring it back up again, that's an onerous development loop, but it's one that we actually forced on our customers if we're telling them this is the way that you customize your application. So, so I think, it took us a while to kind of catch up and realize that this was not the right way to do things. It was, at least a couple of years of living in this world. And there were some real upsides to that. Even, even just shipping the open source and letting customers modify their own code, it certainly did let customers scratch their own itch. So that's an upside. Our Atlassian devs then could focus on the sort of 90% use case. We're just really trying to solve for the broadest possible case. It's certainly meant for stickier products. As customers were able to change the product and make it do what they needed it to do, they were all the more loyal customers. And we started to find that devs who customize evangelize. This is kind of early days of developer relations kinds of thinking, but these, JIRA was a product for developers more or less, and so those developers, when they customized it, would tell other developers how great it was. So and hence led to our spread. But there was certainly a downside. So the customization became, especially over a couple of years, led to some customers that just simply could not get to the latest version. There was no way they could merge their code changes back together. There was considerable pain about building the entire product that we were then forcing onto our customer base. Overall, it led to a poor, you use the word plugin, but without having some kind of notion of what customers might do to our product, they would do anything. And so we had customers blaming us, or rather end users blaming us for a bad product experience that was actually given to them by their administrators. That might even happen a little bit today, but imagine how much customization could have been done with just, with only source code. And overall, that meant a support load that continued to climb, and not just a support load that could be handled by any support engineers, but had to be escalated to our developers. And so that was a real burden that we really just couldn't handle. So that brought us into a new age. But before I move on, let's pause and think about the security concerns, because we'll return to the security idea a few times. Pretty much, this was a day and an age of self-managed software. So our opinion was kind of the same as any other software that you might buy, and it was you buy it, you run it. Not quite the modern idea that we have of you build it, you run it. But and that meant we weren't giving a lot of concern to the security of that application. It was something we expected you to run behind your firewall, and if you wanted to expose it to the world, well, that's on you. So that brings us to 2004. Confluence and JIRA were both Confluence had kind of grown up in those couple of years, and the first generation of plugins came along. We use this term service provider interface. I'll explain that in a bit. But that's a little bit narrower than just general APIs that you can use to customize some products. I'd characterize what we had then as a naive plugin system, because we wrote it from scratch. It was just like, hey, we have to get beyond letting customers modify this code. But that started getting us into an approach where our own development was more of a modular monolith. So at least we were starting to carve out parts that could be characterized as plugins. A bit more, I don't know, so I guess some folks would consider these terms put together an oxymoron. But I still think it's a good milestone for anybody who has a monolith now to start figuring out how to break out parts of what they have and be able to assemble them. Now, it didn't solve all of our headaches. Like for JIRA, the application still had to be restarted to add new plugins. But since the addition of plugins became a matter of changing the class path, at least the recompile cycle could be much shorter for targeting a plugin. So I don't know, anybody remember JIRA 3? Yeah. So yeah, you can see how far things have come these days. So what were plugin points? Plugin points were something like the menu that you have across the top there, and our kind of realization that, hey, there are certain targets within the user interface where people want to extend what you can do there. Okay, so if we take that to its logical conclusion, all right, there's another set of things, the user actions. There's another one over there with the kinds of views that people have, or another one in terms of which columns are available, or down there with the issue types. Okay, so there are certain targets, and we called them web fragments. They were places where you can extend the user interface. All right, so now, just, like, I don't know, trigger warning if you are sensitive to source code, about to show some source code, but in kind of, very dumbed down HTML, we would have had just like hard-coded links for the various options in a menu, and then converted that in order to have a plugin system where there's an interface that has basically the text part of that, what are you going to see when you look at it, and the link, and then implement that in Java code that, for some given set of text. Here's the href, and then there's the string that would map to it. So then we would change the code that looks like this to have more of an iterative loop so that it would go over all of the plugins, pick up the text that you're going to show, put that into the right place, and then know what it points to. Okay, so this gets me to that explanation of what that SPI is. So, or service provider interface. So if in general terms, an API is the application programming interface, something that you can do inside of source code to change the way the application behaves, then a service provider interface is a more narrow idea that lets you add some functionality to the host application. Facebook apps have are kind of good example of this. You write some kind of app, something like Farmville. It's embedded into the Facebook user interface. To end users, it looks and feels like a Facebook feature, but it's actually a separate application that's implemented as part of Facebook's service provider interface. So again, the big idea is API is kind of a big thing. SPI is this specialization, but both share this word interface. And that's where some of the intent comes in. So I guess one of the things that I would call out here is what effectively separates the two is an idea of replaceability. So that means that we can unplug a service provider interface, a plugin, and plug in a new one, and get some kind of new behavior. So that interface idea is, really helped solve some problems for us. We have easier customization by end users now, much smoother upgrades. People can keep up. They just have to add the add-ons again. There's more consistency in the user interface. At least we're just kind of adding the new elements to the same rows. Modular architecture, and much simpler to implement for people who wanted to make changes to their own application. But then there are some technical details that made that still a little bit painful. Shared class path meant high coupling between plugins. So if an add-on wanted to add something to the menu and then something to some user options, they had to know about each other directly. There was also no real public API delineation. So nothing to say like, okay, so these are the places where it's okay for you customers to extend the interface, and where we want to, like we don't want you to change things. And then there's still this need to restart to install plugins, and we weren't using a standard plugin model. It just wasn't that easy to do. Okay, so in terms of governance, I come back to like the idea of governance as a set of constraints. So rather than constraints on human behavior, these were constraints we were putting into the into the code itself. But it unlocked a fledgling ecosystem. Like this is really when JIRA's ecosystem started to expand. And there's I think it kind of established a precedent even that is still true today. So if you buy it, you govern it. So now we're kind of into this, like some of the big conversations are about governing the kinds of plugins that you put in there. So one of the customers that I was talking to recently, I had to kind of tell them we have to get a hold of the plugin use here. You're approaching 200 plugins. That's an awful lot. Let's start saying no to adding more. And or this customer. Yes. Or you have to start saying no to some of these requests or even reducing that. And do you know what the JIRA admin asked? Is there a plugin for that? Right? So there's this, that's the kind of mindset of like, plugins are these wonderful tools, but they can get you in some governance trouble if if you aren't following some of the guidance we were talking about here. But I think the key here is that this, there's an idea about governance that, constraints can be useful things. They can help people, they kind of help your processes and behavior scale a lot faster, and that's how we have unlocked this wonderful ecosystem we have. Okay, so we get into the 2007 era, and our products are starting to explode. We had acquired Bamboo, Crucible, and Fisheye, and we still wanted to have this marketplace experience, but we really did, we needed to get beyond a lot of those developer pains that were preventing us from going further. So P2 grew up in this era, or plugins 2. It's an OSGi-based dynamic loading, dependency isolation. I don't know. Without kind of dwelling too much in the details, it did overcome some of the pains about restarting the system when you had to make changes. So made for faster developer loops and a much better user experience where you could add the plugins without having to restart the system. So that gets us into a service-oriented monolith. So now things are actually quite a bit more separate. Rather than being just carve-outs or cutouts inside of the application, these are really kind of separate things that you can build. They had their own development pipelines, so we could build them separately without having to rebuild the whole application. I gotta mention this, that a lot of that came from the benefits of OSGi. What it stands for won't help you understand what it is. So OSGi is the Open Service Gateway Initiative. But if, I know it's kind of fallen out of favor, but if folks know Eclipse, the Eclipse IDE was built very much on OSGi and does some things that we'll show in the next couple slides kind of quickly. Again, hopefully it won't trigger too much reaction. So the idea is like in Java world, you have these dependencies between plugins. They are usually manifest on the class path. So you kind of what you are pointing to is fixed by what happens when you start up the JVM. What happens is that in the OSGi world is that you actually declare what those dependencies are in a manifest. And so when a plugin starts up, it looks at its manifest and then uses that to resolve which dependencies that it has. Right. So this kind of adds a kind of overhead that the original plugins didn't have, but a flexibility of that you don't have to restart things. So yeah, we get into this kind of interesting cycles, where if you have, one of the things about the class path is that if you have two versions of this, two different versions of the same thing like common lang, OSGi knows how to handle that so that you don't have to do as much keeping up all of the sets of jars or libraries that you have to the same version. All right, so that gets us into, okay, we had a pain with shared class path, no public API delineation, a need to restart and install plugins, and a non-standard plugin model. Well, OSGi helped us with the shared class path, took that problem away. No API delineation. Part of that idea of the manifest is it declares what is a public API. The need to restart plugins is just a feature of the OSGi itself, and OSGi is a standard plugin model. Okay, so mostly P2 addressed all of the problems that we had in that old model. And one of the things that really helped us achieve was real independence in the build pipelines themselves. So now we had different teams that could work on different parts, and that really allowed us to get to a different place in terms of shipping products. So were folks around for the JIRA 7 release? We kind of remember maybe switching our product offering from just the big JIRA to now several flavors of JIRA, JIRA Software, JIRA Service Desk being the biggest there. And the important difference there is that, like, we needed that separation to be able to have different business models for these products. Without a kind of technical separation that we could do with OSGi, we really wouldn't have been able to license that in a different way. Okay, so at this point, the plugin architecture was starting to mean something different to us. We're getting over these developer headaches, but we wanted to become a cloud company in this era, right? So we're talking about between 2007, 2014. You mentioned you've seen some of the iterations we've done in cloud. So a lot of those first attempts were just take our self-managed product and put it into the cloud. But customers had already by this time come to depend on plugins very heavily. You wouldn't just value JIRA on the merits of it alone. It had a lot to do with the kinds of possibilities that were available for marketplace applications. So for a very short time, we did run JIRA in our cloud with plugins that you could add, and the overhead was just absolutely crushing. So we could, and we couldn't really rely on that kind of self-hosted argument. Well, you bought it, so you secure it. Like if a plugin were leaking data or exposed the application to exploitation, that's on us because we were offering this as a service. So the P2 kind of model had really reached a limitation when it came to cloud. And that brings us into this kind of like around the 2014 era is when we came out with a new approach, cloud-centric, called Atlassian Connect. By this time we had HipChat, so we're all remembering HipChat these days. We do still have Bitbucket. Confluence and JIRA had made their way to cloud as well. And why did we do this? Well, so we've got these SaaS products, and in order to secure them, we need to be able to run third-party code in an out-of-process way. If it's in process, that means it has access to things that maybe it shouldn't. We wanted to be able to continue to improve the user experience, so we wanted to take all of those lessons from old plugins and see how we could step up our game there. And then we definitely needed to pay attention to cloud architecture, what things are happening on the web. So building up Atlassian Connect is a layer on top of the old plugin model, at least in technical terms. Uses the same marketplace to serve up the apps, so there's a lot of reuse there. P2 apps are still available for those who are doing server and data center, as you probably well know. In the cloud, the same REST APIs are still available for both server and cloud, so there's commonality there. And Connect provides really just kind of a new model of integration. So not just extensibility, the way that plugins did, but new ways to connect to third-party cloud services. And how does it do that? So a module is called, whenever a module is called, let a third party inject a new feature. So I'll circle back. If you remember the earlier concept, we called that ability to extend things a web fragment. And we kind of really exploded that idea. So this is some code that you would use to describe an add-on in the new world. So this describes where an add-on is hosted, which is a web service, which modules it uses. Modules are those web fragments. And then scopes, and this really gets us into starting to secure things. So we have these idea that your app now has to ask for what kind of access it wants to the Atlassian application. And then some kind of authentication also, so that third-party applications can recognize the JIRA user or Confluence user that it wants to talk to. And all of this is done, it's kind of a subtle thing here, but this is all done descriptively. This is code in a sense, but it is also just declarative code. It's not the kind of thing that you have to write in Java. So that has opened things up for other people to build on as well. So I think long ago we looked at Java and OSGi as the development platforms. And we were finding we needed, much more support for when we work with third-party integrators. That Atlassian Connect now provides a kind of platform for anybody to build on that isn't just based on Java or this, crazy OSGi thing. So, and inwardly, we were starting to build new things as services as well. So. Around this age, we were starting to put some common telemetry across all of our products in something that we were calling logging as a service. There's also, this is when we started to build out some of the first attempts at Atlassian ID, so a layer of authentication of user identity that would work across all of the products. And it would eventually evolve into something that could support SAML SSO. So again, helping with end user security. And also we were starting to peel away some different features, even as we worked with the same source code bases between server and data center, we were replacing some of the things that we were shipping to customers for storing things like attachments with something that would better fit in the cloud, a sort of media service. That lets us take in things like Office docs and PDFs and images and put them into JIRA and Confluence. Okay, so it's about this age when we were thinking about webhooks, about features as microservices. And as an example, if Bitbucket was a pipeline or platform that we were building on, we built the feature of Bitbucket pipelines as its own separate microservice, and the ability of Bitbucket to emit webhooks also as a microservice. So this is really starting to diverge from the way that our on-premise products work, which continues to be very monolithic. So this is also the era in which Atlassian goes public. So that's not that long ago, but that subjected us to additional scrutiny at the financial level. And that translates into a layer of technical governance that private companies often don't have to worry about. For example, Sarbanes-Oxley requires us to have IT controls so that any software change that might have a fiscally or financially material impact goes at least we know what happened, when it happened, who did it. And as a software company, it's kind of scary because it means what we sell to customers is our software. That pretty much means every change is subject to those kinds of regulations. So I know a lot of organizations, when they kind of hit this, one of the ways that they attack this kind of governance issue is with a traditional separation of duties. That's where a lot of times the interpretation is dev can't touch production and ops can't make source code changes. But we decided we really wanted to work with our auditors to help them understand that, the kind of automated approach that we wanted to take. So we do have a kind of separation of duties, one that makes sense to auditors, but isn't necessarily in terms of the separation of dev and ops. It's more about if somebody can make a change, they can't delete the record of that change. And that's also a kind of classic auditing approach. And we also built in automation into our CI/CD pipeline that would detect and prevent inappropriate actions, like code changes that weren't reviewed and approved by peers. And once our auditors understood how we were doing all of this, they were actually quite pleased, because the controls that we have put in place are often more effective than the kinds of manual controls that some other companies have. So a lot of this comes out of kind of a lot of this, the technical things that we put in place, the ability to build all of those services in small pipelines made it a lot easier to put those kinds of automated controls in place. All right, now it's a kind of short story, unfortunately. So, around 2018, we were rebuilding our chat approach with Stride, and under the hood, what's that? Yeah. So I was thinking about putting instead of that, a little bit of a rip slide on there, but it still demonstrates something. We've come into a time when we really wanted to have, rather than the products themselves be platforms, we needed a platform that was providing us things that we could build products out of. And so Micros is our kind of PaaS, if you will, our platform as a service. It's when we were shipping Stride, it was entirely microservice composed. So there were different parts of the application that you could do. If you wanted to mention somebody, there was a microservice calling that up. If you wanted to send an action or you like capture decisions, there were different microservices for those pieces. And what's really significant here is that around the fall of 2017, when Stride was really ramping up, our product management and design folks started to think differently about how they wanted to talk about products. And they came up with this idea of the Atlassian teamwork platform. So they were kind of where technically we were building out Micros as a platform as a service, they were starting to think in platform terms too. And so these elements that they described are their attempt to think in those elements, to kind of reconsider how products are built and designed. So they're starting with a very microservice-oriented approach. They're like, that's even kind of pervaded their way of thinking and planning. Okay, so I'll return to this idea of ecosystem. It's not only important that we compose our products from elements as microservices, but it's also critical that we work with other vendors' services. So this means integrations. This means for identity, things like those SAML providers that help people bring their own user bases in. For media types, so extending beyond just ones that are like Microsoft Office. And we want our software tool chains to work better with tools for infrastructure as code or for the cloud. So there's all kinds of reason why we want better ecosystem. Now, one of the very recent things that we've had to go through and has kind of moved us to better security as we work on this ecosystem is that we put a lot of effort in to satisfy GDPR. So inside of Atlassian, we refer to those letters as general destruction of public roadmaps. It's been very disruptive to have this come along. However, while the regulation is mostly focused on privacy, it has helped us to better understand some key aspects of security. For example, we used to have user records, including usernames and passwords, across multiple applications. Bitbucket had its own usernames and passwords, and JIRA had its own usernames and passwords. And that meant that there's like a really broad attack surface on all of these products. If you get into JIRA and were to get its data, well, then you'd be able to get into Confluence and Bitbucket and maybe even some third-party products. So fortunately, GDPR, because in order to satisfy this idea of right to be forgotten, we have to start to collect the user's data into one place so that we could possibly delete it. And that's meant that we've narrowed that attack surface. Now there's just Atlassian Access that has all of that information in it, and then opens up the possibilities for customers to be able to do two-factor authentication or other security measures like password standards and timeouts, resetting after a certain timeout. So I think for us, the important thing of like pulling all of that information into one underlying service was something that let us implement our own security policies in one place. So it made it a lot easier to get more secure faster. So, I'm looking back, I wasn't even here for the whole journey, but it has been quite a long one from our open source-ish days where we realized we needed extensibility to where we were offering more like replaceability, the ability to plug other things in through a service provider model, to the things that we did in the OSGi days to make our builds more independent, to make sure that we could separate teams out and have separate teams building different pieces of the application, to our first features like Bitbucket pipelines written as a pure microservice, and then into the days that we are now where we have an underlying platform called Micros that we can build on top of. So without all of the technology around that, the most important thing is that it's really all of those steps have allowed us to build a thriving and viable ecosystem without which we wouldn't have been successful. So for that matter, our microservice story isn't some kind of happily ever after. We're certainly not done with that. It's just an ongoing journey. Okay, so I just want to close on one key thought. So if you're starting your microservices journey now, go there with a company that's been on that journey for over a decade. We've targeted and focused tools that reflect that experience. And if you need help combining those solutions into something comprehensive to help solve microservices and governance and security problems, then I hope you'll go with a knowledgeable solution partner like Expium. Thanks.